Hello, welcome to the IBM Cloud Certification Series. Today we're going to talk about messaging in the cloud. After completing this module, you'll be able to understand MQLite messaging use cases and benefits, understand the tooling available in IBM Bluemix MQLite Service Dashboard, what the difference is between MQLite messaging models, explain worker offload pattern using MQLite to make an app more responsive, and finally, understand delivery assurance, API, and language support. Let's talk about some basic terminology involved in messaging. First, what is messaging? Messaging is a technology that enables high-speed asynchronous to program communications with reliable delivery. In this context, programs can communicate with many packets of data and call messages to each other. On the left-hand side of the diagram, there is a sender or producer. In the middle, there is a queue or topic, and at the end, there is a receiver or consumer. So what is a topic? It is a channel through which users subscribe to receive a specific message from a producer. A queue is a channel through which all users pull the messages that they want to receive using a point-to-point model instead of automatically receiving messages. A producer submits a message to the queue, and the receivers can browse through the queue and decide which message they wish to receive. There are two types of messaging models. One is point-to-point, and the other is publish and subscribe. Let's look at some trends in cloud application architecture. The left side of the diagram shows you how the data center architecture is designed. Everything is on-premise on the data center. You can test, deploy, and operate as a whole. It has a powerful integration runtimes and homogeneous technologies. The one caveat is that it is often oversimplified. On the right side, we see a cloud-centric architecture. With this architecture, you can have a small empowered DevOps teams own each microservice. You can test, deploy, monitor, and operate individual services. You can use polyglot languages and persistence, and the services scale automatically as necessary. With the cloud-centric architecture, there is a lot more efficiency. On this slide, you can see what the MQLite service looks like inside of Bluemix. You have different options in pricing and setup, so you can customize it for your needs. Messaging provides a higher level set of abstraction with which you can build your applications. The advantage of messaging is that you can build applications that scale very easily. On this slide, you can see some sample use cases for MQLite. The examples shown are worker offload and event-driven. For worker offload, it does what the title implies. Intensive work is offloaded and distributed amongst worker processes to be performed asynchronously. Some of the things you can use it for are processing images or videos, as well as performing text analytics. In the event-driven use case, you can take one or more actions when something interesting happens. For example, when a build finishes, you can email logs and update dashboards. Similarly, when a video is finished transcoding, it is uploaded automatically. Here are a few more use cases for MQLite. At the top, we have what is called delayed processing. With delayed processing, you can schedule a task to happen at a specific point in time. This is ideal when you want to run a detailed report when your app usage is low, or generate an end-of-day summary. When the end of day approaches, the summary will be generated at the time you specified. Third-party integration ensures that your applications remain responsive even when third-party systems are not available or responding slowly. You can use third-party integration when you want to update an existing CRM system or book an appointment. We will now look at the MQLite user interface. Starting with the first number on the list, we have the link that shows you all of the messages in a tab. You can click on the documentation tab, for example. Number 2 on the chart shows you the number of clients that are connected, as well as who is sending and receiving messages. 3 shows you the history of the messages. 4 talks about the username and password. 5 is the area where you can see the sent messages and by what sender. 6 is a drop-down in which you can filter by specific clients. 7 is where you select the pattern that you want to look at. 8 is the area that points to the receiver and their information. 9 points out the topics. 10 shows you how you can stop or start processing. 11 shows you the status of the process, whether it's successful or not. And in 12, you can see information of the price of the messages that are received. Finally, 13 gives you a description of the patterns, and you can also see the sharing ID. As described in the first few slides, you can see on the chart that there is a sender, queue, and receiver from left to right. On this slide, you can see a sender application is sending a message to a topic address space. The message being sent is hello and world, and the topic is called test A. The consumer can then subscribe to that topic to receive that message. It is a simple send and receive. On this slide, we see the publish-subscribe model. Similarly as before, a message is being sent, but in this model, a message can be sent to multiple destinations. Now we see what's called persistent destination. You can use this model when an endpoint is down and you still want to update the status of your message. This is an asynchronous model that will wait until the client comes back on to publish the message. The message is persisted in the destination layer. In the sharing model, a sharing ID is used by two consumer applications. It can be shared with two clients. In client takeover, there can be a backup application that can take over the message. You can use this when your original client does not come up. MQLite can be used to improve the level of responsiveness that a user experiences when interacting with an application by offloading the work from an application's main event loop. A key factor that determines the responsiveness is the amount of time that the web server takes to process an HTTP request and a sender's response. This can lead to situations where the server can no longer keep up with the rate at which new requests arrive and the web applications become unusable. In application 1, it takes 5 seconds because it waits for the load to be processed at the end. In application 2, MQLite is designed to offload the work to another process and cut responsiveness significantly. So what are the types of messages supported by MQLite? Payload is either text or binary. Content type is used by clients to transfer JSON, and you can have a per message time to live. MQLite supports two qualities of service or QoSs. At most one delivery, which means the message will usually be transferred at once. At least once delivery means messages will be transferred once. However, the situation may arise when a message is transferred or duplicated more than once. At least one copy of the message will be transferred to a recipient. Each time a message is sent from the client to the MQLite server, it is transferred using one of these QoSs. Finally, you can acknowledge or reject messages as well as take control over the number of unacknowledged messages delivered or linked credit. On this slide, we will talk a little bit about the languages that are supported by MQLite. Some of them are Ruby, Python, and Java. MQLite is based on AMQP, which is used to receive, queue, code, route, and deliver the messages. It is an open standard wire protocol, which is a simple programming language, neutral messaging model. It is compatible with any open source AMQP clients with idiomatic language and framework API mapping, which makes for frictionless deployment. Finally, the OpenWire protocol facilitates community drivers for languages and frameworks. Here are some resources that you can use to get more information about MQLite on Bluemix.